Resonance is the language we talk to atoms with. A quote by Wolfgang Kettler, the physicist and Nobel laureate, during one of his lectures at MIT. It seems that ancient Egyptians understood that resonance is the language we use to talk to nature and applied that in many aspects of their lives. Let's first talk about the concepts of resonance and then see how ancient Egyptians potentially widely applied these concepts. Resonance at a certain frequency is finite damping. That would mean after the system is driven, the oscillation does not last for an infinite amount of time, and that implies that when we drive the system and look at the response as a function of frequency, there is a finite width for the driven system. In many ways, the damping time and the finite width are related by the Fourier transform. Atomic physics is interested in every single possible aspect of this resonance. The shape of the curve, how it can be modified, what happens when we tie it strongly, what happens when we tie it weakly, etc. We usually characterize oscillators by the sharpness of the resonance. The sharpness of the resonance is the ratio of the beats of the resonance and the frequency, or the inverse of it. So if you have an oscillator at a kilohertz and the resonance is 1 hertz wide, we say the resonance has a Q, a quality factor of 1,000. And that means you can observe 1,000 oscillations before the oscillation decays away. The Q factor explains how fast energy decays in an oscillating system. It compares the frequency at which a system oscillates to the rate at which it dissipates its energy. The sharpness of resonance, described by the Q factor, increases or decreases with an increase or decrease in damping. As the amplitude increases the sharpness of resonance, the Q factor decreases. Higher Q indicates a lower rate of energy loss and the oscillations die out more slowly. A pendulum suspended from a high-quality bearing oscillating in air has a high Q, while a pendulum immersed in oil has a low one. Resonators with high-quality factors have low damping so that they ring or vibrate longer. The frequency of light is 10 to the power of 15 Hz. The wavelength is 300 nanometers, for example, the Q of the rotation of the Earth. It fulfills all of our requirements for resonance and oscillations. It is a periodic phenomenon. It has a Q of 10 to the power of 7, so the precision of the rotation of the Earth is better than 1 part in a million. The quality factor Q for a pulsar star is 10 to the power of 10. If a resonance has a high quality factor, the more sensitive it will be to tiny little changes. A high quality oscillator is a tool for discovery. The resonant frequency is the oscillation of a system at its natural or unforced resonance. Resonance occurs when a system is able to store and easily transfer energy between different storage modes, such as kinetic energy or potential energy, as you would find with a simple pendulum. Most systems have one resonant frequency and multiple harmonic frequencies that get progressively lower in amplitude as they move away from the center. Resonance describes the phenomenon of increased amplitude that occurs when the frequency of a periodically applied force, or a Fourier component of it, is equal or close to the natural frequency of the system on which it acts. When an oscillating force is applied at a resonant frequency of a dynamic system, the system will oscillate at a higher amplitude than when the same force is applied at other non-resonant frequencies. Frequencies at which the response amplitude is a relative maximum are also known as resonant frequencies, or resonance frequencies of the system. Small periodic forces that are near a resonant frequency of the system can produce large amplitude oscillations in the system due to the storage of vibrational energy. Resonance phenomena occur with all types of vibrations or waves, including resonance of quantum wave functions. The energy quality is based on the shape of the wave. When we say the shape of the wave, we are referring to the proportion of the wavelength to the amplitude, irrelevant of the single measurement of frequency or wavelength. This quality can also be expressed by the angle at that the wave crosses the central axis. In other words, the relationship of the amplitude to the wavelength is the main factor determining the energy quality effect of the wave on its environment, which could also be expressed in the form of the angle of intersection of the wave with its axis. This concept was mentioned in the book Back to a Future for Mankind by Ibrahim Karim, an architect who is a graduate of the Federal Institute of Technology, Zurich, Switzerland, and teaches at several universities. It was mentioned in a different context related to how biogeometry assesses the effect of a wave on the subtle energy systems of its surroundings due to the quality of shape of that wave, as mentioned in the book. Remember, we just mentioned that we usually characterize oscillators by the sharpness of the resonance. The sharpness of the resonance is the ratio of the beats of the resonance and the frequency, and that the Q factor explains how fast energy decays in an oscillating system. It compares the frequency at which a system oscillates to the rate at which it dissipates its energy. What if there is another factor that could be added to the beats of the resonance and the frequency? This would be the angle of intersection of a wave with its axis, which would determine the effect of the energy of the wave on its environment. An example of that would be Earth. We mentioned that the Q of the rotation of the Earth is 107. It fulfills all of our requirements for resonance and oscillations. But we know as well that we can now observe the Earth's axis to be tilted 23.5 degrees from the plane of its orbit around the Sun. But this tilt changes. During a cycle that averages about 40,000 years, the tilt of the axis varies between 22.1 and 24.5 degrees. Because this tilt changes, the seasons as we know them can become exaggerated. More tilt means more severe seasons, warmer summers and colder winters. Less tilt means less severe seasons, cooler summers and milder winters. It's the cool summers that are thought to allow snow and ice to last from year to year in high latitudes, eventually building up into massive ice sheets. This is a direct observation that the angle is affecting the environment and that the angle could actually be the main factor leading to this effect, not the Q factor. The thinking goes here that resonance changes the amplitude of the wave, which leads to changing the angle of intersection of a wave with its axis, leading to a different effect on the environment or field or system. It seems that ancient Egyptians had a pretty advanced understanding of these concepts. They understood that resonance is the language we use to talk to nature. The sharpness of the resonance is the ratio of the beats of the resonance and the frequency, or the inverse of it, the Q factor, and how fast energy decays in an oscillating system. It compares the frequency at which a system oscillates to the rate at which it dissipates its energy. If a resonance has a high-quality factor, it will be more sensitive to tiny little changes. A high-quality oscillator is a tool for discovery. The resonant frequency is the oscillation of a system at its natural or unforced resonance. Resonance occurs when a system is able to store and easily transfer energy between different storage modes. Resonance describes the phenomenon of increased amplitude that occurs when the frequency of a periodically applied force, or a Fourier component of it, is equal or close to the natural frequency of the system on which it acts. Resonance phenomena occur with all types of vibrations or waves, including resonance of quantum wave functions. The energy quality is based on the shape of the wave. When we say the shape of the wave, we are referring to the proportion of the wavelength to the amplitude, irrelevant of the single measurement of frequency or wavelength. They utilize this knowledge to achieve balance and harmony through resonance. Likely, the pyramids and the obelisks were basically tuning tools, receiving, amplifying, and distributing a balancing force comparable to the B-force, which is one of the complex forces proposed in the book The Big Defreeze of the Universe and the book The Pre-Dynastic Kings and the Pyramids of Egypt by Muhammad Hassan Algari. The obelisks likely acted as antennas, receiving and distributing this energy with the required wavelength. The design, locations, proportions, patterns, and material of the obelisks were carefully selected to effectively achieve those functions. The ancient Egyptians had advanced geometrical measurement devices in the form of scepters, staffs, and pendulums to detect energy qualities. We find such sophisticated detection instruments depicted in their artwork held close to their hearts and in their hands. According to biogeometry, the ancient Egyptians used several methods of connection through resonance with the heavenly locations in the sky, such as the areas marked by the Milky Way, the Pleiades, the circumpolar stars Orion and Sirius. Dr. Ibrahim Karim has been able to confirm this theory through measurement using modern detection instruments of biogeometry. To ancient Egyptians, the buildings were like musical notes within the overall composition of a symphony that included the energy anatomy of the location on Earth and also of the locations in the sky, as well as time and natural cycles. To the ancient Egyptians, this sacred energy quality became so natural and normal that they interacted with it in their daily life and used it to bring harmony into every aspect of their environment. Rings a bell? Yes, the Maat concept. Maat was a fundamental concept in ancient Egyptian religion and ethics. It represented the idea of truth, justice, balance, and cosmic order. The concept of Maat was personified as a goddess who was the daughter of the sun god Ra. The concept of Maat extended beyond the afterlife and into the mortal realm. It was believed that the harmony and stability of the universe depended on the observance of Maat in everyday life. Therefore, it influenced various aspects of Egyptian society, including law, ethics, governance, and personal behavior. The principle of Maat emphasized maintaining a just and balanced society, where truth, order, and fairness prevailed. It was regarded as a guiding principle to follow not only in one's actions, but also in one's thoughts and intentions. The idea of Maat had a profound influence on ancient Egyptian culture, and is reflected in their art, literature, and religious practices. It remains an essential part of the understanding of ancient Egyptian civilization and its worldview. The ancient Egyptians used several methods to achieve resonance with locations in the sky, reproducing sky patterns on Earth by mirroring produced resonant connections. This mirroring of the sky on Earth is a practical way of bringing to the Earth the sacred energy quality found in certain stellar regions. It is achieved by creating a pattern of sacred energy spots on Earth, with the same pattern as a stellar configuration in the sky to create an Earth-sky resonance. For them, the stars were markers for the intended energy areas in the sky. An interesting comment from Dr. Ibrahim Karim. What might seem to be miracles to us today were to the ancients applications of their sacred ancient sciences. In the same way, modern mobile phones or televisions would seem like a miracle to them, and to anyone who is not familiar with our type of power or energy, electricity. The difference is the type of power used. The powers of nature that we use today in the form of electricity, magnetism, or gravity work mainly on a physical level. The ancient Egyptians, however, worked with the powers of nature in their holistic form, affecting physical, vital, emotional, mental, and spiritual levels.